A few more slides, then we conclude chapter 9. We start chapter 10 of this afternoon. Right? Okay, so the last part of chapter 9 is on the heat treatment. So what happened when you do heat treatment? You will see something called martensite. Okay, so it's not a new material, but it changed form from alpha to something. So it's a ion carbon martensite rapid cooling or squinch. So this is what you see just now, right? So what happened here is we are using this line to form the martensite. FeC, Fe plus the carbon. So this one, if you want to form, you want to do lead martensite, then you focus on this area. You want to have plain plate martensite, you do this one. If you want to do both, you do this one. Okay. Okay. So you change austenite to martensite. So it looks something like that. So when you squinch it, then you form something it's called BCT, body-centered tetragonal. But this is outside our scope to on this one, right? So on the line, you see MS, martensite start temperature, the black line, and the temperature at which transformation finish is called martensite finish, MF. See here. Okay, so what is happening here is you start from this 0.2% carbon, then until the one that you want, any point along the black line here. Okay. Rest you read. So from here, it change phase from BCC alpha into BCT crystal structure. Okay, what I want you to show these slides is from BCC distorted into BCT. So as you can see here, this is the beginning. So the largest hole that you can have in the gamma FCC, this is a phase crystal structure, diameter is 0.104 nm. Here. Again, if you want to prove this one, you can go back to chapter 2 or chapter 3, where you can calculate the R and A, and there is a gap here that can be found. Okay. Size of the carbon also can find the table in chapter 2 or chapter 3. As you read, So this one is carbon percentage and hardness. So this is hardness. Vickers and Rockwell is a different. How to differentiate this one also, you're going to read how we measure hardness. Viscous, we use diamond head. Rockwell, we use different head, different shape of head. They have a round head and so on. Okay, so there's a table for hardness test. So go and see what is Rockwell, what is hardness. All right. So as you increase your percentage of carbon, your hardness increase. Because more and more carbon. So hardness increase and so on. So this is another table for plain carbon steels. So if you want to buy metal out there, you give the supplier the code, 4 numbers, the 4D number, 1010, it means something lah. There's a catalog there. So if you want to have 10% carbon, then you give 1010, and they have a 0.4 mn, and these are the tensile strength, yield strength, range that you have lah. So these are application. Okay, So after this module, after you graduate, so at least you remember from this module, when you want to purchase, there's a code there, 4-number code. Okay, so this is a summary of heat treatment. So you can see from austenite, you can form 3 perlite, bilate, and martensite. It depends on how quick you cool them. If you slow, you get this one. This is what we learned previously. Okay, we slow it, cool down, we get this one. Moderate cooling, you get this one. Rapid quench, you get this one. And you reheat it, you get tempered steel. So again, all these are the coding. They have AISI, SAE coding, and so on. So each have their own meaning. Okay. So SAE is Society of Automotive Engineer. AISI is American Iron and Steel Institute. So if you're doing your FYP dealing material, remember to refer to all this coding. So when you do FYP already, don't just mention steel. What kind of steel? What code you use? And so on. So there's another standard called British Standard, BSA. But BSA, they use six code. For example, 070M20. Okay. So, but usually we use 4-digit lah. We use AISI code for only 4-digit. Okay. Another code called UNS. They call it Unified Numbering System. Look like this one, AA6061. This one, if the AISI system is 6061 for aluminium, but if you use UNS, you call UNS A96061. So there's an equivalent. You can go online and search for equivalent between the system here, between AISI, British system, and UNS. It depends on which country you work in. Okay. Okay, another one is standard steels. Standard steels, don't forget chromium. The thing that make it either is non-stainless steel or standard steel is this percentage, is this member here. You have a chromium, sure it is part of the standard steels. You want to make standard steels, you add chromium. You add chromium. Chromium is Cr. Okay. So why chromium can help corrosion? Because it forms oxide on the surface. So there are 4 types of standard steels: ferritic, martensic, austenitic, precipitation hardening. This one you read lah. What we're going to test you is how you make standard steels. How you make standard steels. We use ferritics with its BCC structure. We add chromium from 12% to 30% chromium. So we just add in chromium atoms and carbon atoms like that. Okay. So this is called substitution strengthening mechanism. We have 2 types of mechanism. One is substitute, one is interstitial. Carbon one is interstitial. This one, chromium, is substitutional. Okay, so this is another graph. Iron chromium phase diagram. So you have ferrum on the left, chromium at the right. So you have liquid, alpha ferrum, chromium, gamma, and sigma. So there is a gamma loop here. Gamma loop. Okay. Here, there's a gamma loop here. Okay, if your your chromium more than 12%, it do not go through the FCC become BCC transformation. So these are the code for alloy and standard steel's code, and how many percent of chromium? How many percent of chromium? And in your mechanical properties chapter, use the tensile strength here and use strength. So these are the standard steels, microstructure, and so on. The word that you see in encyclopedia, the word anode, ANNELED, this one is heat treatment. It means heat treatment. Okay. Okay, the rest you read. So certain type of process give you certain type of standard steels. This is austenitic standard steels. So austenitic standard steels is between 16% to 25% chromium and 7 to 20% nickel, which is around here, this region that I highlight on the screen here. Okay, the rest you read now. So these are the example of austenitic standard steels. Okay, with this we conclude chapter 9. Okay. Okay. See you guys at 4 o'clock. Okay.